Right, hello guys. Sorry about that. Things broke for a sec. How's it? Things working? Give me a comment because it's been a bit iffy today. I tried changing the resolution, so hopefully you can still see everything. Um, yeah, it looks right to me, but let me know if it's bad. All right. Yes. So today we're just gonna a couple of things we got to do. First of all, to the register. Could you guys comment here if you're indeed here? Hope you had a nice weekend. Right, register is here. Cool. So we've got Samuel, Kezia, Zach, Hannah, Casper, Regan, Dan, Joseph, Sam and Isaac. Um, Sam, Isaac. Cool. Anybody else here? We're still missing Frank, Carrie, Lottie, Sam, and Will. Are any of you guys here? Cool. Right, let's just get started. Right, yeah. So last week we were looking at. Oh yeah, last week you had Friday's lecture, which broke. That was good. Yeah, hopefully you all had a chance to go over what didn't work on Friday. So we're going to start with that today. So we are looking at. We're going to go over all the types of hypothesis testing at once, so you guys can like contrast and compare the different methods. And then we're going to start working through a past paper. Right, so if you guys could first of all have a think about, we've got 3 questions here. Which type of hypothesis test is each question asking you about? So have a quick think. I'll give you guys 2 minutes just to see what you reckon. And if you could comment 1, 2, and 3 and what kind of hypothesis test they are. So 2 minutes on the clock starting now. Have we actually done these questions, Dan? This is what broke on Friday. We started the past paper. Oh, cool. Sorry, how far did we get through it? I assumed that you guys were 1 lecture behind everybody else. Turn up to the end of question 2. Oh, sweet. Easy peasy. Okay. So we did this one, and we're on to question 3. Cool. The cat question. Was question 2 the cat question? We did these. Dan, I don't know what cat means. I do vaguely remember a cat question, but is that question 3? No, question 2 on those previous ones. Oh, I see. Cool. And then the stream broke. Gotcha. Okay, so we haven't done any of the past paper questions, and we haven't done any of this stuff yet. Ah, okay, cool. Fun. Okay, let's go back. Gotcha. All right, so we're doing question 3. Cool. All right, so I believe I believe this is where we got to then. I don't remember much from Friday because I was quite stressed with all the breaking things. So yeah, right. If you guys try this, 4 marks. I'll give you 4 minutes to do it. Should be nice and easy. Everything you need is there. So you'll need your calculators, but it should be pretty straightforward. Comment if you need any help, and I'll be back in 4. Yeah, Dan, if you want to do skills checks, you can for 4 minutes. We'll pretty shortly be moving on from this one to the past paper. If you guys have already done this, can you comment saying I've already done this? Because I know I did say to you guys to watch the Wednesday feed, but I don't know how many people did. So yeah, if you've already done this, please comment and tell me. If you haven't, that's fine. We'll go through it. But I don't want you all to be sat there thinking, "Oh, it's a waste of our time." So let me know in the comments. Okay, cool. No one commented, so I'm assuming that you haven't all done this. So we'll just work through this like as planned. I reckon Dan in about 15, 20 minutes will be up to where you got to anyway, so that's fine. Okay, so table shows temperature here, so we need to put all this stuff into our calculator. We're going to be testing at the 2.5% level, so if we look through the 2.5% column, and our sample is 1, 2, 3, 4, 5, 6, 7. Sample size 7. So that's going to be this row here. So our critical value is going to be 0.7545. And we're trying to find if there's negative correlation. So our critical value is minus 0.7545. Okay, we ought to state our hypotheses. So H0 rho is 0, H1 rho is less than 0. So we'll bring up the calculator. We're going to type in all the data. And we're going to go to, yeah, okay. Delete all that. So 17.5, 18.5, 18, 24.6, 22.2, 3.1, 27.3. Cool. 1010, 1011, 2, 997. Cool. So calc, set it up, make sure you got list 1 and list 2 there, which we do, and then we're going to go to reg. So my R value is 0.79. Or minus 0.792. Okay, so the question is, is our value critical? So it's 0.792 is less negative. Sorry, it's more negative. It's closer to 1 than 0.7545. So it is critical. So minus 0.792 is less than minus 0.755. Therefore, critical. Therefore, except H1. And there is evidence to suggest that temperature, as temperature increases, pressure decreases. So there is evidence to suggest negative correlation. I'm going to bring here. Negative correlation between temperature and air pressure. Cool. All right, moving on. Okay, so for the rest of this week, I wanted to work our way through a mechanics statistics past paper. I believe this is the 2018 paper. I think so, yeah. So I'd like you guys to try this. So question 1 is worth 5 marks. So I'll give you guys 5 minutes to do it. And this one can be quite tricky. It's all to do with stuff from last year. So uniform distributions and how is cloud cover measured. So have a think, see if you can remember how those two work. So 5 minutes starting from now. Cool. All right, sorry about that, guys. I didn't realize the resolution had gone a bit iffy, so hopefully you can all see it now. Right. So. Okay. Yeah. So we got a cloud cover. We want to do a probability distribution. So let's try and let's just draw it up here. So we got random variable c. Cool. So we have little c, and then we'll have probability that c equals little c. And the trick here really is to remember that cloud cover is measured in octas. So octas, remember, are eighths of the sky. So there could be no clouds. There could be 1/8, 2, 3/8, 4/8, 5, 6, 7, or the whole sky. So overall there are 9 categories. It says it's a discrete uniform distribution, which means each of those probabilities is going to be 1/9. So uniform means the same. Cool. So that's the answer to part A. There you go. Part B, find the probability cloud cover is less than 50%. So less than 50% of the sky would mean less than 4/8 of the sky. So we need to add all these probabilities together, which is going to be 5/9. Because there are 5 categories there. Okay, cool. All right. Helen then used all the data from a large data set and found that the proportion of days with cloud cover less than 50% was 0.315. Okay, let's see. So we got 5/9, and 5/9 is 0.55. So we got 0.55. So we're quite a bit off there, to be honest. We're looks like more than 10% away from our value. So I would say that's not very suitable. So not very suitable. 0.55 is far off. 0.315. Okay, what could be an appropriate solution, appropriate refinement to Helen's model? Well, the problem with Helen's model is it assumed the probability of cloudy and not cloudy for each octa was the same. It was 1/9. So it's unlikely the probability of it being completely cloudy and completely uncloudy are the same for a time for the whole year. So the a good refinement would be to not use a uniform distribution. So don't use a uniform distribution. Or you could say something, maybe don't use a discrete variable. You could use a continuous variable instead. Cool. How do you know how to include the 4th column? Because it says, oh, hang on, less than 50%. Yeah, you might be right there. I think actually 4/9 should be the answer, so I would have just lost a mark. And 4/9 is 44%. Yeah, well spotted there, Sam. 44%. Or 0.44. Okay, it's still pretty far off though. I'm still right in my conclusion. I'm still keeping that the same. But yeah, well spotted, Sam. Yeah, there should be 4/9 because it said less than 50%. 4 would be 50%. We want to go less than 50%. And I know because we're saying less than 50% of the sky. So 50% of the sky would be 4 octas. So we want less than 4 octas. Yeah. And again, that's because she's used a discrete model. If she used a continuous model, it would be a different story. Okay, cool. Next question. All right. Hmm. Let's make this a bit bigger so you guys can definitely see it. And this one doesn't fit so well, but there's not much there that's much use anyway. Yeah, cool. Right, hopefully you guys can see this. So this one, I've just covered it up, is worth 7 marks. So I'll give you guys 7 minutes to try and solve it. There you go. Cool. Right, so 7 minutes on the clock starting from now. Okay, welcome back, guys. Cool. So yeah, pretty interesting question. So we got a shop, blah blah blah. We know the PMCC for the data is 0.915. We're trying to test whether or not there is a negative correlation between sales figures and weekly temperature. So my null hypothesis, rho equals 0. Alternate hypothesis, rho is less than 0 because we're looking at negative correlation. Suggest a possible reason for this correlation. Well, people are shopping. It's sunny. People won't want to go shopping when it's sunny. So, plus it's a seaside town. People at the beach, not shopping. Okay, so she suggests a linear regression model could be used, and we got strong negative correlation. So yeah, a linear regression model would be suitable. Yep, so strong correlation means a linear model is suitable. State which variable with the explanatory variable. So explanatory one is the one that causes the change. So the temperature would cause the weekly sales to drop. So temperature. It is the temperature that causes sales to drop. Okay, so we calculated the linear regression equation. There's that. Given interpretation of the gradient. So the gradient is minus 171. So for every rise of 1 degree C, weekly sales weekly sales drop by 171 pounds. So we didn't even need the oh wait, we haven't actually done the hypothesis test. Oh my god. Sorry, I forgot first bit of the question. 5% significance level is there. 8 weeks is there. It's terrible. So yeah, ours is not minus 0.915. It's less than minus 0.6215. Therefore, accept H1. Forgot the whole point of the question there, but yeah, no one picked up on it. Regan did it. Accept H1, the correlation is negative, etc. Yeah, good. All right, anybody got any questions about this one? It seems this was the most recent bit of learning that we did. You guys acquired this knowledge purely through YouTube, so if you understood it, it's a good test of the system. Cool. Right, let's move on. So next one. So question 3. I'll try and make that a bit bigger, but there's only so much space on the screen. And you probably can't see all that, so that needs to be slightly smaller. Can you guys see this? I think that's the best I can do with this one. Yeah, okay, give it a go. It's quite a big question. 4, 5, 6, 7, 8, 9, 10, 11 marks. I'll give you guys 11 minutes and we'll go through them. So this one is all about probability distributions. So lots of table work for this one. And a bit of binomial as well by the looks of it. Cool. Right, so 11 minutes starting now. Cool. All right, guys. So yeah, I think Dan had some good answers on this one. Make sure you're all commenting if you are trying these at home. So we've got binomial model. So H, binomial, 10 throws, 0.1. State two assumptions. Well, you got 2 out of 3 choices. Trials are independent, so throw probability, or each. Let's just say each throw is independent. Otherwise, we're mixing 2 things. Each throw is independent. We got a fixed probability of hitting target. And fixed number of throws. It's worth 2 marks. I think the first 2 points you made are better. Fixed number of throws is kind of obvious in the question, but it is still one of the conditions for a binomial model. Okay, so now we want to try and, I'm just going to get rid of that so I've got some more space. We're going to try and find the probability h is greater than or equal to 4. So we need to bring up the calculator, and we're looking on a binomial model. So dist binomial, BCD, lower is 4, upper is something big, number of trials 10, probability success 0.1. And we get 0.0128. Let's save that one, which, yeah, cool, good, well done, Dan. Okay, next bit. So for each child, the random variable f represents the number of the throw when the dart first hits the target. Okay, so we're trying to find the probability it takes a child 5 throws to hit the target. So for that to happen, we need to have 4 misses and then 1 success. So a miss is a probability of 0.9. So we're going to need 0.9 to the power 4 because we're missing 4 times. And then after that, we want success on the next time, so we're going to times that by 0.1. And the reason we can times them is because they're independent. So 0.9 to the power 4, and then times it by 0.1. And we get 0.0656. So that's our probability of hitting it on the 5th attempt. Okay, and then Thomas assumes that in the model, no child will take 10 throws. So he comes up with a different model of this. Okay, so this time we're going to want to write down a probability distribution. So no child's going to take more than 10 throws. F is the number of throws which the child hits the target. So they might hit the target the first go, second, third, fourth, fifth, sixth, 7, 8, 9, 10. And maybe that should be n instead of f there actually. N for the number of throw, and we use probability f equals m. So for the first throw, the probability is 0.01 plus n minus 1 times alpha. Now n is 1, so n minus 1 is 0. So for the first value of 1, the probability is just 0.01. For the second one, we get 0.01 plus n is 2 this time. 2 minus 1 is 1, so we get plus alpha. And this pattern continues, so we get 0.01 plus 2 alpha plus 3 alpha, etc., 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 until we get to the last one, 0.01 plus 9 alpha. Okay, so we want to try and find alpha, and we know all the probabilities have to add up to 1. So if we add all these things together, it's basically turned into an arithmetic sum. Because the first term was 0.01, each time we're adding on an extra alpha. So we're going to remember the arithmetic sum equation. Sn is n over 2, 2a plus n minus 1d. N in this case is 10, so we get 10 over 2. Sn, we know the sum has to be equal to 1, so 1 equals 10 over 2. Lots of 2, lots of 0.01, plus 9, lots of alpha. Cool. So if we solve that, we find that alpha equals, let's work this one out. So we get alpha equals 0.02. Cool. Okay, next bit, using Thomas's model, find the probability equals 5. Well, for that, we're just going to put the data in, so we get 0.01 plus 4 lots of alpha, and alpha is 0.02. So we're going to get 0.09 for that one. Cool. And the last bit, explain how their models differ. So, Peter thinks that the model's probability. She thinks that the probability is binomial, so the probability of success is the same each time. Thomas thinks that your probability of success is going to increase each time. So he reckons that each time you throw the dart, you're going to get slightly better. So let's write that down, and that's it. So Thomas, I don't know, just say Thomas thinks probability increases each throw. Peter thinks probability is fixed. Can we not use a calculator for part C? What was part C? It was written over it. Yeah, give me a second, we'll go for it. F equals 5. No, you couldn't use the calc. I don't think you could use the calculator there, because if you use the binomial distribution, you'd end up with NCR times the correct answer, because it has to be. There's not like a number of ways of getting it. It has to be miss, 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 hit. Yeah, you got to have 4 misses followed by a hit. You can't rearrange that and get like hit, miss, 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 hit, miss, hit. You can't rearrange it. There's only one outcome where it works. So Sam, no, you can't use calculator for part C. And yeah, it assumes that once you hit the target, that's it, because that's all we're counting. The variable is the number of the throw on which the dart first hits the target. So that's why you can't use a calculator for that one. Right. Anybody else got any questions before we move on? We're doing pretty well for time today. We hopefully should be able to get through most of the stats part of this paper. Okay. Oh. So question 9. Box plots. Should be an easy question. Can you all see it though? I know it's quite low res, but yeah. Have a check. See if you can see it. If you can, brilliant. If you can't, let me know and I'll try and chop it in half or make it bigger or something. But yeah, so this one is 13 marks. Oh my god. So I'll give you guys 13 minutes. It should be an easy question. It's mainly asking you about the basic, maybe slightly more boring bits of stats, but definitely the more basic bits of stats. If you can't see it, you can always zoom in. So if you hold Command and Scroll or Control and Plus, you might be able to zoom in on it. So what I say, 13 marks, 13 minutes for this one. Comment if you need any help.
What I'll do, guys, in 5 minutes' time, I'll focus on the bottom of the question. So if you have a look at the bits there, A, B, and C, and then in 5 minutes I will slide down to the rest. Cause yeah, I don't want you to hurt your eyes squinting at the screen. So yeah, give that 5 minutes, and then I'll scroll it down. Cool. Right. Oops. Moving the wrong thing. Let's go through the first part of this then. I'll leave it all big and zoomed in. Why not? Okay. Yeah. Some good chat in the comments this time. So try and keep that up, guys. It's good. So name the sampling method that Charlie used. So it was opportunity sampling is the name. Opportunity because he's sampling the people that are there and then the people that walk into the office. What did you guys put? Yeah, opportunity, good. Part B, state and briefly describe an alternative method of non-random sampling. The only other one is a quota sampling. But we need to explain how we can do quota sampling. So we could split company by age or department, whatever, and then make sure our sample needs to reflect these quota. And just so you're clear, you're not random, I would say, and ask people what department they work in as they walk in and fill each quota. So make sure you've briefly explained quota sampling and also kind of shown why it isn't random. Okay, part C. So Taruni has asked every single person, and she's asked every single person, so therefore it's a census. Cool. Which is what you guys all heard. Excellent. Okay, moving on then. Let's move this table down. Oh, maybe move up a little bit. Cool. So Taruni has put her data in this thing. Okay, write down the interquartile range for this data. So the interquartile range is going to be, what's the lower quartile is 26, I think. Upper quartile 58. So subtract those and we get 32. So the IQR is 32. Calculate the mean and standard deviation. Okay, well they're giving us all the stuff we need. So the mean is going to be 41133 over 95. And standard deviation is going to be the square root of 202294 over 95 minus 4133 over 95 squared. Okay, so if we work all those out, and I won't show you guys how to do this, it's just typing stuff into a calculator. The mean should be 43.5. And the standard deviation should be 15.4, which Kezia got and Regan got as well. Brilliant. And Sam got. Well done, all of you. Good job, guys. Okay, state whether you'd recommend using the mean and standard deviation or the median interquartile range to describe the data. Yeah, Kezia, good answer there. So, you can see that we've got two extreme values. We've got these two outliers up here. Now, these outliers will affect the mean. They'll drag the mean up. They will also affect the interquartile range because they're dragging the spread out. What they won't affect is the median because the median is the middle value. So because these are the two greatest values, if I moved these greatest values and plonked them here, it still wouldn't affect any of these values because there's still 25% of the data below here, 25% from here to here, 25% from here to here. So it wouldn't actually affect it. So extreme values don't affect the median and the interquartile range. So because our data has extreme values, the median and the interquartile range are the best two to use. So they are unaffected by the extreme values. Or call them outliers, whatever you want. Okay. So two people have left and moved house since they had their data collected for this this box and whisker. So Let's make some space. Did you guys see this one? Maybe it didn't show up on your screen. So two values that are changing. So someone's Rana has gone from 75 minutes, which was here, to 35 minutes, which is here. And David has gone from 60 minutes, which was here, to 33 minutes, which is here. So how's that going to affect it? Taruni needs to redraw her graph. What does she need to change? So it's not going to affect the oh, you guys tell me. What do you reckon? Which parts is she going to need to change? It says she's going to need to change two of them. The value she's got, well, there's the lowest point, the lower quartile, the median, the upper quartile, and the greatest value. Which two of those are going to need to change? Any ideas? The mean isn't on here anywhere, Dan, so that's not one. I think you mean the median though. Yeah, it's the median and the upper quartile. So because we put more data below the median is going to move lower, and the upper quartile as well. Put more data below it, so the upper quartile is going to get made lower. So Q3, Q2, decrease both. Because we've put more data below them, so their values need to be made lower. Cool. Right, we've got 10 minutes. We'll see what the next question looks like. Maybe we can start it and we'll finish it on Thursday. Let's have a look. As soon as it loads. So guys, things have frozen a bit here. Yeah, it's a 13 marker. We're not going to finish it, but you guys can definitely get started with this today. So yeah, 14 mark question. I'll give you the rest of today, and then we'll also spend the first 5 minutes on this on Thursday. So I'll just write down A to D, 5 minutes, Thursday, starter. Just so I remember where we got to. But yeah, if you want to spend 13 minutes on this now, that'd be good. Wait, well, 10 minutes now. So from now to the end of the lecture. Let me know if you need any hints. It can be quite difficult, this question. The key bit to remember, I'll underline it, is the calculator requires 4 batteries. It will stop working when any one battery reaches the end of its lifetime. So bear that in mind. See how you get on.
Cool, right, guys. That's it for today. So, yeah, Thursday. See you next. We will probably get through most of this paper on Thursday, I think. And yeah, cool. Don't forget to log on and do the teaching and learning survey on Moodle, and you should still be doing the skills checks as well and uploading those to Moodle as well. Let me know if there's anything I can help with. Otherwise, I will speak to you guys on Thursday. Cheers.